Next topic is linked list. Linked list is a linear collection of data elements called nodes, where the linear order maintained with the help of pointers. Linked list is also called as one-way list. Each node in the linked list is divided into two parts. First part is called as info. First part, suppose A, it's info, means data. And second part is link, that is pointer to next node. First part is called as info part, which contains the information about the element or actual element. And second part is called as link part, which is next pointers field, that is it contains the address of next node of the list. For example, consider linked list having 6 nodes. This figure shows linked list with 6 nodes. The left part of node is info part, which contains information of the element, while the right part of link is a link, which is next pointer field, that is it points to the next node. The arrow is drawn from link, one node to the next node to indicate link. The address of list is stored in start or name of the list. The link part of last node, this is last node, 6th node. Its link part is null. That is, it contains nothing, means there is no next node after this last node. So it is blank or it indicates null. The trace of linked list, we just require the address of start, means we just need a start node to trace the linked list or to trace the start of a linked list. There are some advantages of linked list. To store array in memory requires consecutive memory locations, means linear memory locations, while to store linked list, consecutive memory locations are not required. Arrays are not be easily extended, while linked list can be easily extended. In linked list, we can add nodes easily and delete easily. There is very complicated procedure to insert an element in an array, but insertion in linked list is easy. Similarly, deletion of an element from array is very complicated, while deletion from linked list is easy. Linked list can be easily implemented and maintained in computer memory. Now, next topic is how linked lists are represented in memory. A linked list can be represented in memory by using two arrays respectively, known as info and link. Means we can store linked list in memory using two arrays. First array is info and second is link. Info and link contains information of element and next node address respectively. The list also requires a variable name or start, which contains address of first node. Means start node contains address of first node. Pointer field of last node denoted by null, we know that, which indicates the end of list. For example, consider a linked list given below. A linked list with 4 nodes that are A, B, C and D. Address of A is 5, it's stored in start node. Address of B is 9, is stored in A. Address of C stored here. Address of D stored here. Now this linked list can be represented in memory as there are two arrays. First array is info, second array is link. Now there are 9 memory blocks, 1 to 9. And at the first position here address of D is 1, so D is stored at this location. Address of C is 4, so C is stored here. Address of A is 5, so it's stored here in 5th memory location. B. Address of B is 9, so B is stored here at the memory location 9. Now second array is link. First node D, link part of D is null because it is last node. Last node contains nothing, means here null. C stores address of D, that is 1, so 1 is stored here. A contains address of B, that is 9, so it is stored here. And A contains address of B, that is 4, so it is stored here. Now next point is insertion into linked list. It is easier to insert an element into linked list or delete an element from linked list than arrays. For insertion of an element into a linked list, the only requirement is that free memory space is available to store a node. For example, consider a linked list having 4 nodes that are 26, 94, 89 and 65. Now this linked list represented in memory here. First array is info, second array is link. Address 1, address of 94 is 1, so 94 is stored in here. Address of 89 is 4, so add location 4, 89 is stored. Address of 5 is blank, so all the arrays store at the 3. And here is the link part. At node 94, it contains link of 89, that is 4. 4 is stored here. 26 contains link of 94, that is 1. 1 is stored here. And these two arrays are completed. This is how linked list can be represented in memory. Now, to insert an element on, suppose we have to insert element on second position of this list. Now at first position 26 store here, we have to insert 39 here. Now fifth block is blank in a memory block, so we store 39 at a fifth block. So address of 39 is 5 and its link part contains address of 90, that is address of third node. Now address of this second node store at the first node, that is 5 store here. This is insertion. Now how it is displayed in memory? Only at fifth position 39 is stored. So this is insertion of an element in a linked list. Next is a deletion from a linked list. To delete node from linked list. To delete a node from linked list, the link part of node is given to link part of the previous node. For example, suppose consider following linked list with 4 nodes. These 4 nodes are represented in memory like this. 2 arrays, again info and link. Now deletion. Now to delete a second node from the list, then just transfer the link part of second node to the link part of first node. Means only delete second node is 94. So we are deleting 94. Only address of net 89 is stored at this link part. Only deletion of this node. Just transfer the link part of second node to the link part of first node. This is represented in memory. Only we deleted one node. So next point is stack and queue. Stack means LIFO system, that is last in first out system. In LIFO system, in this type of system, the element which is inserted at last will be deleted first. Means last in and first out. Stack is an example of LIFO system. It is a linear system in which insertion and deletion takes place only at one end, that is top of the list. The insertion operation is referred as push operation and deletion operation is pop operation. For example, consider stack of dishes. Suppose here is stack of dishes. Here is first dish store, after that second, after that third. Okay. Suppose we want to add a new dish to this stack, then it is added at the top. Suppose we have to insert fourth dish, then we have to add it at the top of the stack. We cannot add this at middle or at last. Also, we want to delete a node or deletion, then it also from the top of the stack. In stack, insertion operation is referred as push operation. Means if we insert a dish into stack, it is a push operation. If we delete the dish in a stack, then it is a pop operation. Next is FIFO queue system, that is first in first out system. It also referred as queue system. In this type of system, the element which is inserted first in the list will also be deleted first. Means first in and first out. Queue is an example of FIFO system. A queue is a linear list in which insertion takes place only at one end of the list, known as rear of the list, and deletion takes place at the other end, called as front of the list. For example, a queue for tickets in a cinema hall. Suppose there is a queue for a ticket, person A, person B, person C, and person D. Person A come first, then it takes a ticket and go first. Means first come, first out. This deletion in this queue, deletion is referred as rear.